And we're going to proceed with the next 10 questions. So 21, a wave pulse moves along a stretched robe in the direction as shown. Which diagram shows the variation with time t of the displacement s of the particle p in a rope? So the wave pulse will move towards the particle p, and if it moves with the same orientation, particle p, a little closer to particle p will kind of go up like this, will go left like this, will come down like this, and will go up back like this. Correct?
Yeah.
Because that's how the wave is moving. So that's exactly what will happen. That will kind of like be the same shape of the wave here, and that's how particle p will move. So displacement, somewhat, it goes up, then left, then diagonally down, then up. I believe C is matching that. Nothing really else does. So we're good with that. 22. A wave has period t, wavelength lambda, and amplitude a. A wave is shown on a graph of displacement x against distance d. Which graph is correctly labeled? Are you kidding me? Okay. Anyways. So it has. What are you supposed to say? Period t, wavelength l, and amplitude a. Now.
C is not because time period दिया हुआ है t पे.
Yeah, and like this amplitude would be obviously be this, right? So
Yeah.
you can simply cross a C and D basis on the basis of that. Amplitude is from the mean position to the peak. It is not from peak to peak. It is from mean position to the peak. Anyhow, so now the reason why it'll be A and not B is because both of these, well, if this is distance, if these are both x, they both do show one particular wave. That's understandable. However, B would be correct if instead of distance here, there had been time. Only then would, like, you know, if you measure this, this would give you time period. If it's distance on the x-axis, then, you know, from if you look at one wave, yeah, it gives you wavelength. So it's 22A. 23, the table lists possible orders of magnitude of the wavelengths of some of the principal radiations of the electromagnetic spectrum. Which row shows the correct orders of magnitude of the wavelengths? I hope you remember this. So do you remember at least how did we used to remember the electromagnetic spectrum?
Yeah, then based on them, it's C.
Okay. So can we list down the order though? It used to be what? Radio waves,
microwaves, infrared, visible light, then ultraviolet, for X-ray and gamma ray.
So I used to remember this by read my instructions visible under X-ray glasses.
Wow.
but okay, so even if you don't remember anything, let's try to approach this question if you don't remember anything, but you would know that this has the highest frequency, which means the smallest wavelength, and this has the, you know, greatest wavelength, and that is the pattern. So if you look at this, ultraviolets should be bigger than infrared, because ultraviolets should be smaller than infrared, because here lambda is decreasing. So in a way to put it, infrared should be greater than ultraviolets, which is true in this, which is in fact true in this, which is in fact true for all. So like, okay, that doesn't give us much. Mike, in fact, are they maintaining the? Yeah, they're maintaining the same trend: microwaves, infrared, ultraviolet, X-rays. So the trend is being maintained here. So
I think most people would know that visible light is like from 400 nanometers to 700 nanometers, right?
Definitely. So that's 400 nanometers. If you write you can basically write 400 nanometers as what? It's 400 into 10 to the power 9.
4 into 10 minus 7.
Yeah, so that's in 10 to, it's 4 10 minus 7. This is basically into 10 to the power minus 7 something. 4 basically, and 4 or 9 or whatever. But yeah, okay, so continue.
So now infrared ka jo hai, infrared should have a greater wavelength.
all right,
and
which
ultraviolet.
crosses out like your A and B, because their
Yeah,
infrared has a smaller wavelength. So you're left with these two, and perhaps what you're going at is also how ultraviolet should have a smaller wavelength.
yeah.
So smaller wavelength would be 10 to the power 8. 10 to the power 6 would give you a greater wavelength, which is not what you want. And through that,
Hmm.
you can figure out C. And hence, even if you didn't remember anything, as long as you remember the wavelengths of visible light and the hierarchy and how wavelength changes, you can figure it out. Okay, this looks like a pretty large question. 24. A vehicle carries a microwave transmitter that emits microwaves of a constant frequency. A stationary observer has a microwave receiver. Oh, I think this is the Doppler effect. Okay. The
Yeah.
vehicle moves directly towards the observer at constant speed. So if you know this is the observer, let's say this is some dude.
At least get my spelling right.
Anyhow, the idea is the vehicle is moving towards the observer. I was never very artistic. The vehicle then accelerates, still moving towards the observer, travels at a higher steady speed for a time, and then decelerates until it stops. Okay, what is the
Right.
variation? And so for this, what is the variation in the frequency of the microwaves that are detected by the observer? Now think of it like this: when it's accelerating, moving towards the observer, it's traveling at a higher steady speed, which means the waves are getting more squished. As you move towards something, the waves get squished towards each other. Instead of this, for example, they end up like something like this. And if you move faster, the waves get more squished. Is that right?
Yeah.
So if the waves gets more squished, then that's another way of saying that the distance between the waves is less, the distance between the wave fronts is less, or the frequency is greater. So if it accelerates, the observed frequency should rise, okay, and then it travels at a steady speed. So the observed frequency should remain steady because now the wavelength, the degree of wave squishing, you could say, is the same. So the wavelength is the same, so the frequency is remaining the same. When it
Hmm.
decelerates, then the waves are more spread out. If they're more spread out, lambda increases, which is the same as saying frequency decreases, because obviously v is equals to f lambda, in case that wasn't obvious. So like they follow an inverse relationship because v has to remain constant. Anyhow, but lambda increases,
Constant.
frequency decreases, so it would fall, it would return to frequency fo. I would believe it would return to frequency. Wait, towards.
No,
No.
it
Yeah,
would lower frequency
yeah.
because the vehicle stopped.
And the reason is because initially the vehicle was still moving towards the observer. If it was still moving towards the observer, FO, which was the frequency when it was moving towards the observer, would still be greater than it would be if it was stationary. Because if it's moving, there's still some degree of squishing of waves and so on. But now it's just stopped completely. So there's no squishing waves, nothing of that sort. So the frequency is less than FO. Are we good? The diagram shows the CRO displacement of an electromagnetic wave. The time-based setting is 0.2 microseconds per centimeter. Which statement is correct? So all the statements require you to find the frequency. So let's do so. You can find the frequency by first finding the time period, which is this. If you know this is 1, then the time period should be 2 centimeters. But again, time period can't be in centimeters. You have to convert it. So it's given here, it's 0.2, it's 0.2 for 1 centimeter micro, and hence it will be x for 2. So you kind of just multiply this by 0.2 into 10 to the power minus 6 because micro,
Yeah.
which is giving you what in time
Point
period.
4.
Um,
Uh,
so in
0.4 into 6.
0.4 into 10 to the power minus 6. So it's giving you this many seconds. For frequency, you just do 1 upon time period. So you just flip that. And then you're going to, whatever you're going to get, you're going to divide that by 10 power 6 to get it into megahertz.
That's 2.5.
So it's 2.5. On those grounds, you can just cancel out C and D. And it wants you to know which region it lies in, whether it's the microwave region or the radio wave region. Now, this is where a bit of memorization comes into play.
Each वाला question देख लो.
Yeah, you could do that. I mean, you do know that if it's radio waves then microwaves, radio waves have a greater wavelength. We don't know the wavelength though, so we could potentially calculate the wavelength, but that would just be a little. Anyhow, in fact, maybe if we do calculate the wavelength, that would help us figure out. Ideally, you would have just memorized the frequency, but if you don't, because you know that V is 3 into 10 to the power 8 for electromagnetic waves. You know the frequency, which is 2.5 megahertz. Can we quickly calculate the wavelength to give us a good idea?
120
what?
meters.
Oh, nice. So 120 meters. So that would probably be your radio wave, I believe. Radio waves have high wavelengths. Even if you look at the previous question, which gave us an idea, yeah, microwaves are still into 10 to the power minus something. So if you want, if you want 120, this is more like 10 to the power 2. So you want radio waves, which have even larger wavelengths than microwaves. So are we fine with saying B?
Yeah.
Let's go on to 6. In a double-slit interference experiment, light of frequency this much is incident on a pair of slits. Okay. Bright fringes are 3 millimeters apart, observed on a screen some distance away. What is the separation of bright fringes when the frequency of light is changed to 5? So basically, it's decreased. Now, what was the formula for this? It's double slit.
Lambda d over a.
So x is equals to lambda d upon a, and just for our convenience, if v is equals to f lambda, then lambda is equals to v upon f. So we can write this as x is equal to v d upon f a. Again, v is constant.
D upon a constant.
Yeah, so we can basically, in fact, even speed is going to be constant for for light, right? Speed of light is always 3 into 10 to the power 8. So all of this is in a way constant, which kind of leaves you with x is equals to k constant 1 upon f. Anyhow, but how does that help us? We can calculate the value of the constant and then proceed, because we have
frequency की value and उसकी corresponding fringe x की value है.
Yeah. So quickly pop this into our rough formula that we made. K is just your constant. We've taken VD upon A. They're all constants. So constant divided by constant is constant. So we just denoted that by K. And we replaced it with the value of X for this particular frequency. In fact, it's 1 upon the frequency. So it's 1 upon 6.0 into 10 to the power 14. Excuse the bad handwriting. Anyhow, but what value of K are we getting?
1.8 into 1012.
So this is your value of your constant. Now you simply solve. So you place it again in the formula. In this particular formula, you want to figure out x. So you take your constant 1.8 into 10 to the power 12, and you multiply it by 1 upon frequency, because that's your formula. What is your new frequency? Is 5.0 into 10 to the power 14. I believe Ashad has an answer for us.
3.6 into 10 minus 3. That's 3.6 millimeters.
Yeah, and very good. Monochromatic light is incident on a pair of narrow slits at a distance of 0.1 millimeters away. So narrow slits, I believe the slit separation is 0.1 millimeters. That's what they're trying to say. And what was your slit separation? Was that A? Hello? Where did Ashad go? Okay, and slit separation was denoted by which variable? Did we have a variable for it?
A.
A, okay. a series of bright and dark fringes are observed on a screen a distance 2 millimeters away, which was D. The distance between the adjacent bright fringes is this much, which is X. Okay, so what is the path difference between the light waves from the two slits that meet at the second order dark fringe?
Second order dark fringe. So like first order dark fringe with 0.5 lambda. अच्छा तो पहले lambda calculate करना होगा इसका मतलब.
Yeah. So we can if you use the formula x is equals to lambda d upon a, you have x, you have d, you have a. But understand we have to do this for the second order dark fringe.
Lambda 2 है and what's a 0.1.
Yeah, a is 0.1. But what will you take as x though? Because this was the second order dark fringe. What will you take as x?
I'll take it as 1.5 times the fringe distance.
Okay, and the reason you're taking that is because from zero order bright fringe to second order bright fringe it would be 2, but to second order dark fringe it will be 1.5 times x. So x here will basically be 1.5 times, because while he calculates, let me just zoom in and like okay, this was not supposed to happen. Okay, let me just zoom. How do you zoom? Okay, sad life. Let me fix this. Let me fix this. So
Okay.
basically from here to here, this is x, which means from here to here, this would be half x, which means all of this is like 1.5x. And that was what all the painful zooming in was for. So, but anyways, you take 1.5x, you input that into this particular formula using the values that are given in the question. What do you get for lambda?
6 into 10 minus 7.
So you get lambda 6 into 10 power minus 7 meters. They've asked the path difference. What do they think they mean? I'm not too sure. What do they mean by the path difference?
Oh, wait. पहले I think सीधा lambda calculate कर लेते हैं x से.
Okay, so we've done that for this.
Okay, so wavelength of the light जो आ रही है, that comes out 400 nanometers.
Okay, so what was this that you calculated? What was this lambda? Oh, you were calculating x. No, what were you calculating? You were calculating lambda, or because x is given.
I don't know what I'm doing, honestly.
Okay, so let's do this again. Let me just put this inside. So it was 1.5 times whatever values of x you had. Lambda d was 2, a was 0.1. You put this in, you get lambda. What are we getting there?
SN 1.5 नहीं करो अभी.
1.5 नहीं करूँ? You just want to simply calculate lambda.
Okay. Difference निकालना है, right? तो I think पहले direct lambda निकाल लेंगे. उसको देखते हैं.
See, because I don't remember anything that I had done with this. So we didn't do this in A2. So like.
So इससे आता है 4 into 10 minus 7, right?
I mean, you're the one who has the calculator, so like, I'll just take your word for it.
Yeah.
Okay, so you're saying the lambda of the light wave of this particular light wave is 4 into 10 to the power minus 7.
Yeah. And इसके बाद like जब हम first bright fringe पे जाते हैं.
Okay.
Right. So the part difference is 1 lambda. तरह जब आगे जाते जाओगे part difference 2 lambda हो जाएगा second bright fringe पे. Similarly, dark fringe पे जो है वो first dark fringe is 0.5 lambda part difference.
Achha, so that was your path difference. Yeah. This is going to be 1.5 lambda, and hence you just multiply this into 0.5.
So that gives you 6.
which is C.
Yeah.
Okay. Um,
मतलब सही
question.
किया था. There's a better way to explain this way.
Yeah. I mean, we kind of did it a more direct way by taking 1.5x, but that's. Can you just? Is there a way you can explain path difference a little simply?
It's like आपका जब zero order bright fringe होता है तो like वहाँ पे the waves are मतलब बिल्कुल in phase होती हैं तो the path difference is 0 lambda, right? Then the first bright fringe वहाँ पे एक wave थोड़ा ज़्यादा travel करके आ रही होती है, दूसरी wave कम travel करके आ रही होती है. लेकिन since bright fringe बन रहा है, constructive interference हो रही है, और since one wave is traveling a bit more, तो अगर आप distance से calculations करो तो it comes out to be 1 lambda. इतना second bright fringe पे आपका जो पार्ट डिफरेंस कम आउट होता है अगर आप थोड़ी सी कैलकुलेशंस कर लो पूरा डिस्टेंस वगैरह निकाल के कि ऊपर वाली स्लिट से कितना डिस्टेंस ट्रैवल कर रही है, नीचे वाली स्लिट से कितना ट्रैवल कर रही है, तो 2 लैम्डा आता है. तो इसी तरह सक्सेसिव जो फ्रिंजेस होती हैं हर फ्रिंज पे उतना ही मतलब आगे चला जाता है आपका पार्ट डिफरेंस, राइट?
Yeah, and hence, if it was 2 lambda for the second bright fringe, for the second dark fringe, it would be 1.5 lambda.
Yeah.
Okay. So 28, a tube of length L is open at both ends. The stationary wave is set up in this tube when a tuning fork vibrating at frequency fx is held at one end. This is the lowest frequency of stationary wave that can be formed in this tube. Okay.
Yeah.
So this has some significance. And what is that?
It's like the fundamental frequency. So like both open ends पे एंटी नोड होगा एंड बिल्कुल सेंटर में एक नोड होगा.
Yeah. So you have something like this, I believe.
Yeah.
Okay. But can you quickly explain why we couldn't have something of this sort?
Because it says lowest frequency. So like the green one, उसमें you'll have a greater wavelength, a lower wavelength, and wavelength कम होगी तो obviously frequency increases because inverse relationship होता है.
Yeah.
Right?
Yeah. Good thing. Another tube of length 2L is closed at one end. A stationary wave is set up in this tube when tuning fork vibrating at frequency Fy is held at the open end. This is the lowest frequency of stationary wave that can be formed in this tube. So how will
like
be it?
an open end पे and node closed.
Something like this.
Yeah.
Excuse the bad drawing. Assume the end correction for each tube is negligible. Which equation is correct? So if we try to look at lambda here, maybe from that we can figure it out. I don't remember. Lambda used to be measured from where to where?
अच्छा look, in the upper like one complete loop is half lambda, right?
By one complete loop, you mean this?
Yeah.
Okay, so and you have two half loops, which is like the same thing as one complete loop. So we can say length is lambda upon 2, length is half lambda. For frequency fx, right? And in this particular, yeah, and for this frequency, here 2 lambda is in fact lambda upon 4, right? Because this is just half a loop. It's just like something like, it's just this. If I try to draw it neater, okay, I can't draw neater, whatever. Okay.
I forgive you, Naushad exists.
But okay, so now how do we link this with frequencies? Now we know that a frequency y is creating a lambda of half as much than x, right?
Okay, so
like
fy आपका lambda comes out to be 8L, right?
Sorry?
The बड़ी वाली ट्यूब में lambda is equal to 8L, right? Because 2L is lambda
Yeah.
upon 4.
Okay,
So
okay.
lambda is 8L.
So you can do it that way as well. Okay, so 2L is equals to lambda upon 4. In fact, that's the easier way. Not pi upon 4, lambda upon 4. Lambda is 8L, and you can figure it out from here as well. If pi upon 2 is equals to lambda, if L is equals to lambda upon 2, then lambda is 2L, which clearly indicates that, you know, that for frequency y, the lambda is 4 times as much, which means the frequency should be 1/4 because they follow
1/4.
an inverse relationship. So f where fx has to
X
be
is A.
a. Wait.
Yeah. Oh, wait.
So basically, what's happening is frequency y is 4 times less, which means if frequency x was multiplied by 1/4, then you'd get frequency y. So I believe it's D, right? Okay, so very good. What statement gives the condition that enables diffraction to occur? A source of waves moves towards a stationary observer. Well, that enables Doppler effect. I don't know how that enables diffraction. A wave is partially blocked by an obstacle, maybe this, because diffraction occurs if you have a split. It occurs also if there are simply waves going and there's like a cliff or an obstacle that you can simply go around, so it gets diffracted as well there. Two coherent waves are superimposed. Again, diffraction is basically
That's
what?
C is interference, right?
Yeah, diffraction is the spreading of waves, so again C doesn't help. D, two waves of equal speed and frequency are traveling through the same medium in opposite directions. Um, well, let's see.
That's like form a stationary wave.
Yeah, like probably yes. But again, you want spreading of waves, and that happens when they either go through a slit or they either go around an obstacle. So if they're partially blocked by an obstacle, that would also happen. So this is a very common MCQ. You know, they'll give you a cliff, waves going around a cliff, for example, or a particular obstacle, and you have to know that diffraction happens. Anyhow, 30, an electron passes into the space between two parallel plates that are 5 centimeters apart, and which are maintained at electric potentials of 2000 and -500 respectively. What is the electric force on the electrons? So electric force, well, we can say that V is equals to ED. That's one formula. Another formula is F is equals to EQ.
EQ.
So if you kind of simplify this and put this into one formula, you get this.
Acha, V would be
Yes,
2500 here, right?
exactly. So V, remember, is the difference between the two plates. So that's 2000 minus 500, which is giving you V of 2500. Some people will make this mistake. So it's 2500 upon D is 5 into 10 to the power minus 2 because it's centimeters. You need to calculate force. The elementary charge is given on your first page, although a lot of you would know it by now, right? And you just simplify to calculate F.
Yeah, so it comes out to be 8 into 10 minus 15.
Yeah. And the reason why we use the elementary charge is because for an electron, the charge is just E. It is the elementary charge. So let's quickly check our answers. All right. So a little sad news though. So we got 9 right. However, we got 21 wrong, which happens at times. We are, after all, solving on spot. But hopefully now we can explain to you why the answer was D rather than C. And Ashad, please do the honors.
Okay. So, yeah. So that basically जो आपका ग्राफ बना है, that's the displacement of the particle against time, right? Start moving like the wave towards P, right? आपका time suppose कर लो like wave up comes to P at time 2 seconds. Suppose कर लो just. So 2 seconds पे the particle moves up. And then it moves left, suppose कर लो till time 4 seconds. उसके बाद drops down till 6 seconds and उसके बाद ऊपर चला आता है. Now just use this on the graph.
So basically,
so that was like a
yeah.
stupid error.
So basically the idea here is how at a short time, you know, like at small time, it would be going up, like kind of like this. And then it would be going left, and then it would be going down at a later time. So the only mistake we made, we forgot to really factor that time factor in. So, and the reason why C is wrong, A and B are obviously wrong, but the reason why C is wrong is because it shows, what it shows here is that at a later time you're going at this stage is coming at a later time, although it's not. It's clearly going to be the first thing that is happening. The orientation is such that you might think this is the first thing that's happening, but actually this shape is being shown at a smaller time. So this in C, it's showing that this shape is happening first, while it's not. It's like the last thing that's happening. So for it to be the last thing that is happening, it has to be at the late absolute, you know, at a higher value of time.
Yeah.
If you look at the assumed time limits that we saw, well, that Ashad took, hopefully that will clarify it. Anyhow, so that was it for this. And for the last in MCQs, sorry, refer to the video after this one.